to talk about how we use RavenDb in our application and how it helped us and how it didn't, or basically what were the difficulties that we had developing with RavenDb. But before I start, I'm going to tell you something quite exciting. That was a joke, right? So when we started using RavenDb on March 2012, and back then we were developing about 40 points per iteration. By the end of the year, we made it to 100 points per iteration, which was really good. We popped the champagne for it. We know that this increase of number of points in our iterations, it is not just because of RavenDb, but we know a good deal of it is because of that. Because developing with RavenDb is really easy. I'm going to talk to you about two main important reasons that makes it easy to develop with RavenDB, which is one is there is no schema, and one is it's not a relational database. Having no schema makes you makes a developer able to just focus on the model, because we want to do DDD. We don't want to worry about persistence. I just want to focus on the model, the business rules, design my entity, and just simply persist it. I don't want to worry about tables. I don't want to create a script for a table. I don't want to worry about getting the type right, not nullable, nullable, and all of that. RavenDb makes you able to do that. And also, if you are in the development and you change something, it's really easy just to blow away your existing collection of documents and change your entity and just basically persist it again. iDocumentation.save, there it is, your entity. Also, because it's not a relational database, the persistence of your entity is not related, the simplicity of the persistence of your entity is not related to the complexity of your entity. Here I'm showing you, if it works, one of our entities that we actually persist in RavenDB. If you look over here, we got 3 different arrays and 2 dictionaries. Had I wanted to persist this in a SQL Server database, I had to actually create 6 different tables, 1 for the parent and 5 for the children. And so that comes the scripting, the maintaining of the table, and also the foreign keys and all the worries that comes with the relational database. But for RavenDB, it's not like that. It doesn't matter how complicated your entity is, you just design it and persist it. Yeah. With any goodness, there is always a badness. So there were difficulties because of the good things that we actually had. Because there is no schemas, there are some issues. We encountered those issues first time when we were working on this shipment allocation entity. So that entity was used for users to be able to allocate shipments. We developed it, deployed it to production, everything was all right, until the users came back and said, you know what, we want to actually cancel some of the shipments. There you go. We had existing entities in the database, but we wanted to add some new properties, which is those properties at the end, cancelled by user, and cancellation reason. Let's just talk about the cancelled properties. It's a Boolean, which in this case is okay for the existing entities in the database. Because if RavenDB retrieves an existing entity in the database, the default value for the cancelled property happens to be false because it's a Boolean, and it would just work. But it's not always like that. There are issues with not having a schema and not being able to just simply write a SQL script as you do with SQL tables and just update everything in one simple go. One important problem that we had was because we wanted to, let's assume that for a shipment allocation, we wanted to create an index that shows all of the canceled shipment allocations. You cannot simply say filter where canceled property is equal to true, because the canceled property is not there and the index won't work. Also, if you don't actually have the canceled property there on the entity, if a new developer comes along, you actually have to explain the entity to your developer, and you need to say, you know, if the canceled property is not there, it means it is not canceled. But if it is there, if it is false, you know, that's not the type of things that you need to do as a developer. Your entity should talk for itself. You want to do documentation, we don't want to do that. It's just not good. And also, not always the default value that the RavenDb renders for you is what you want on your entity. Let's assume that we had an integer property that the default value had to be, I don't know, 5. What do you do then? Do you want to write backward compatible code and say, if this integer value is null, it means it's actually 5. This is not the kind of things that you wanted to we wanted to do. And what if your entity goes through multiple changes? How long back to the history do you actually want to write backward compatible code? Also, it is possible that when you introduce a new change to your entity, the existing entities in the database are actually invalid. What do you want to do then? We don't want to have invalid documents in our database. So what we did is we introduced versioning for our schema or for our entities. We added an entity schema version per entity. We made sure that if a change happens to an entity, we actually update all of the existing entities in Raven database and get them to the current shape. We also made sure that when we are persisting a new one, we persist the document version or the schema version. And also when we are reading anything from the database, we made sure that the document is in the version that we are expecting, because we didn't want to deal with any issue that an out-of-date document can cause for our system. So if you look over there, the entity schema version, the metadata is what RavenDb just makes available for you. You can introduce new metadata for your entities. So this shipment allocation, number 1, the shipment allocation entity actually has gone through 8 different updates because we are on version 9. So we used that. We also used Raven listeners for persisting the version. If you look here, we are using iDocument store listener. We have implemented before store method of that. This is a RavenDb interface, which what it does, it actually set the metadata of, that's called entity schema version, to the current version of the entity that you are just storing. Therefore, we know that every single entity that is persisted in our database has the version. Do you see that over the back? No? So for for retrieving a document from the database, we use a iDocument conversion listener, which is from RavenDb as well. We have developed the document to entity method of that, which basically happens when you are retrieving a document from the database. What we've done here is we get the expected version for the entity that is just getting retrieved from RavenDb. We get the current version that we are expecting, for the entity, and if they are not the same, we throw an exception. So that's it with the versioning. How having a not relational database caused us issues. To be honest, this is not the right title for it, but I left it there because it was cool to have the goodness and badness exactly the same. But I'll explain what I mean. I'd like you to imagine RavenDB not as one database, but imagine it as actually two databases. One is the database that you actually write to it and also get the entities using the ID, and the other one is the database that you actually use for querying your entities. The write eventually makes itself consistent with the query database, but there is delay. It is different with SQL Server that once you persist something, if you query the same thing, you get exactly the same thing straight away. For RavenDB, it's different. It takes time until you actually get the query exactly the same as what you persisted. To sort of go over that problem, we used a lot of static indexes because when you are actually querying RavenDB or the query database, if you like, RavenDB creates dynamic indexes for you. Creating static indexes makes it a lot faster. But that's still not straight away. That's not exactly the same time. There is always still delay. RavenDB is always eventually consistent because of stale indexes, one important reason, and also because of the denormalized data, which I'm not going to go through it, because you can also get denormalized data in SQL Server anyway. But and Mark is also going to explain how we got over the denormalized data using NServiceBus. So you need to know a little bit about eventual consistency if you really want to use RavenDB. I've got two important points for you that you need to consider when you think about eventual consistency. I'll show you an example in our system of how it is eventually consistent. If you look at RavenDB, but you don't see it really there, it always shows you the number of stale indexes. When there is 0 stale index, it means sort of that the read query or the write database is consistent with the query database. If it is more, it means they are not actually consistent yet. So I'm going to show you how our system gets out of sync at some stages. Here is a generating of a code page. What happens is our salespeople go to that page, they generate a code, and someone in the costing departments uses that code for costing our shipments or costing the customer. So I just generate a code. You're gonna really trust me on that. At the moment it says 0 stale. It means there is no stale indexes. I generated a code, is still 0 indexes. 69 stale indexes, 0 stale indexes. So in that fraction of a second, our system wasn't consistent. When I say that you don't need to be frightened by having an eventual consistency, means that most of the time it actually doesn't affect anyone. So most of the time when the person is going to do the costing, the quote is already there. It's really unlikely that exactly at the same time that someone is generating a quote, someone else is actually going to cost the same shipment. And even if that happens, it's not really a big deal, because let's say that the person goes and looks for the quote and the quote is not there, or it's wrong, or it's expired. If worst comes to worst, they're going to pick up the phone and, I don't know, have a go at the salesperson and say, you know, your quote is wrong, it's expired and all of that, and the salesperson says, no, I just generated one, and everything is fine. The other thing about eventual consistency is, don't tell the user that your system is eventually consistent. So, what I mean by that is, well, it's a joke, because at the end of the day, your business needs to tell you if it is okay to have your system eventually consistent or not. But the fact is, most of the time they won't really understand what you're asking. So if you go and ask them, okay, how up to date do you want your data to be? They will say, oh, I want my data to be up to date, up to the second, you know, and say, are you sure that 5 minutes is all right? Or it's a problem? So no, up to the second. And if you keep questioning them and say, okay, so when you get the data on the page, what do you actually do with it? They would say, you know, I print it, and, you know, as soon as you print, something is out of date. Even worse than that, if you load the page, as soon as you load the page, it's out of date. So we are actually using eventual consistent applications anyway. So all I'm saying is, just be sure you are asking the right question from the right person. I'll explain one more bit before we get to questions, if there is any. It might sound that I actually explain more about the difficulties of working with RavenDb versus the goodness of it. It's not because it is more difficult than it gives you goodnesses. It's because I thought you would get more value out of my talk if I do that. And also there's a lot about the goodnesses that you can get out of RavenDB anyway on the net. That's all I have tonight.